Okay, this lesson is about comparing functions, and in it we're going to compare the properties of two functions and estimate and compare the rates of change of two different functions. So we're going to compare the graphs of linear, quadratic, and exponential functions. So for example, if I tell you that here's the graph of one exponential that approximates the growth in Baltimore, Maryland, represented by this graph, and I give you another exponential function that approximates the population growth in Hagerstown, Maryland, represented by this. What comparisons can we make between the two graphs? How can we use the graphs to estimate things that will happen in the future? That's the kind of thing that we can tell by comparing the two graphs. So let's look at an example of this. George tracked the cost of gas from two separate gas stations. The table shows the cost of gas for one of the stations, and the graph shows the cost of gas for the second station. Compare the average rates and explain what the difference in rate of change represents. So what we need to do here, as you can see, the information has been given in two different ways. We have a table and a graph to compare. So what we need to do here is find the rate of change. Remember, to find the average rate of change over a set of data, find the slope between the first and last data points. So I'm not just going to pick any random points to use for my slope. I'm going to use the first point and the last point. I'm going to use the points that cover the widest range of material in order to find my slope. So the rate of change is the cost per gallon for each station. So when I find the slope, it's going to tell me what the cost is at each gas station. Now remember, for slope, this is the formula we're going to use for slope. y2 minus y1 over x2 minus x1. Okay, so the rate of change for gas station A, I'm able to use the slope formula, and I got about 3. So I took the information off my table here, starting with the bottom point here, $31.61, minus the top value. Okay, and then again the x value here, 10.5, minus the x2 value, or x1 value of 1.9. So I use the top point and the bottom point for my formula. Okay, and then I also found the slope for the other second gas station. Now when I was finding the slope for this gas station, it was a little bit harder, because when I was reading the information off the table, it's harder to tell what the exact numbers are. I can see exactly for my slope, for my y values, I should use the 38.15 and the 2.31. Those are the numbers I have right here. However, for the other numbers, I had to kind of estimate to see what x value corresponds to that. And I chose 13 kind of right in the middle here. And then for this one, I chose the x value of 0.6. So just kind of estimating that. I was like, okay, half of this would be 1, about right there, and then half of that again would be half. And I was like, okay, maybe like 0.6 is a good estimate. And so I got the rate of change to be 2.9, which means that the cost is less at gas station B, which is the answer to our question. Good. Example 2, the graph for the height of a diving board, I think I'm supposed to say diving board, above the water level, ht, in feet after t seconds passes through the points, and they give us 3 points here that the function is passing through. Sketch a graph of the quadratic function that models the situation. Find the point that represents the minimum height of the bird. Okay, so, the height of a diving bird. Okay, so the bird is diving down into the water. Okay, I see. And we are measuring the height. So, what we're going to have to do to sketch this graph is come up with the equation of the quadratic that goes through these 3 points. So, what we're going to do is put these points into our calculator and do a quadratic regression to find the equation. So, you're going to take your calculator, you're going to push stat, and number 1 is edit. Then you're going to put the data into your list 1 and list 2 for your x and y values. and then you hit stat again, and you come down to number 5, quadratic regression, and it gives you the values for the equation that will pass through these 3 points. So now we know this equation that goes through the points, and we can use that equation to find the maximum height of the function by finding the vertex. So after we graph it, we can read the vertex off of it here. The vertex is negative 3, so a minimum height of 3 feet below water level. And last example, let's compare the end behavior of the functions. So here we have negative x squared. How does the end behavior of this graph compare to the graph here of 4 times log x? Okay, so we're going to look at the end behavior. It looks like the x value here, as the x value approaches infinity over here on the positive side, it looks like the function is going to negative infinity. And as the x value over here is negative infinity, the function is going down to negative infinity as well. Okay. On this one, this function is more interesting because it looks like even, okay, for the x going to positive infinity, I can see that as x goes to positive infinity, the function is going up, right? It's going to continue to go up to positive infinity. So positive infinity to positive infinity. However, this function is only getting closer and closer to y equals 0. It has an asymptote right here at y equals 0. It never crosses this line. This function does not approach negative x, or negative infinity, because it never comes over here to any negative values. The x values stay positive, they just approach 0. So as x is getting closer to 0, that's when the function values are going down to negative infinity. Okay, so let's just formalize that. The end behavior for the first graph, as x approaches positive infinity, f of x approaches negative infinity. And as x approaches negative infinity, the function approaches negative infinity. For the second graph, as x approaches positive infinity, the function approaches positive infinity. And as x approaches 0, the function approaches negative infinity. So what that means is that as x approaches infinity, f is going negative, but g is going positive. So that's the difference between these two. Both functions approach negative infinity on the left side, but for the f, x approaches negative infinity, but for g, it only approaches 0. It doesn't go all the way to negative infinity. And that is the end of this lesson.